Hey all, welcome back to my channel. Myself Shiv Prasad, and I hope you are all doing great. Today we are going to solve this problem. This is one of the most important problem and interview's favorite question. Best time to buy and sell stock. So let's try to understand the problem statement. So you are given an array of prices where prices of I in the price of is the price of given stock on the ith day. So generally, if you got an input like 715364 715364. What this problem is saying is you are allowed to buy only once and sell only once. Okay, you need to buy B and sell only once. And you need to make a maximum profit. Let's assume if you buy on this day, I today, that is 0 today. Do you think if you sell on any following days, you're going to get a profit? No, right? Because everything on the right side is less than 7. So you don't get. But if you buy on this day, I today, that is first day for 1 rupee, I'm thinking in terms of Indian currency, rupee. Okay. Then if you start looking at the following days, yes, there are multiple days on which you can sell this one. Like you can sell immediately next day where you get profit of 4 rupees, right? Because you're selling at 5 and you bought it 1 rupee, you got 4 rupees profit. And if you sell it here, you get 2 rupees. But if you sell it here, you get 5 rupees. And if you sell it here, you get 3. So out of these 4 profits, okay, which is the maximum profit? This one, right? So this is all about, okay, I can buy on first day and I can sell on 0, 1, 2, 3, 4, 4 today. Okay, then I can get 5 rupees as a maximum profit. That's all the problem statement basically. If you go through, let's try to understand how we can solve this problem. Okay, the very first brute force approach will be achieving this in big of n square time complexity. How it is? So let's take the same example 715364, right? 715364. So what we can do is, if this is I, right, outer loop I, so we traverse all the elements inside loop, I mean to say, for j. So we check, is there any number, okay, is there any day which is going to be the higher than this? There is nothing, right? Because everything on the right side is less than, if you consider 7 as your buy price. Then you come to this one, I. Now your j will be from 5 to 4, okay, from here to here. And you start checking. If you sell on this day where the price is 5 and you bought on 4, yes, you got 4. This is, let's say you having some max profit as a variable, okay, which keeps tracking the maximum profit. And then this 3, which is not greater than what the profit you already got. This is 6. The difference is 5. So we update this to 5. Then this is 4. No, again not. So here it is the 5. So what you got in the first place, you got nothing. So like that, you for this I, you go on J. So like this, you keep on checking, and at the end you are going to return what is the maximum profit, and this is the variable which you're going to maintain across this operation. So this is going to take actually big of n square time complexity and big of 1 space complexity. Space complexity is fine, but time complexity is not good, right? Because if you submit with this solution, LeetCode will give you time limit exception, and interviewer are also not going to be happy. So now let's see the optimized solution. Optimized solution. Optimized. Okay, so what we can do here is 715364. So we are going to have two variables. One is min, one is max profit. So min tells about what is the minimum amount, okay, at which we are buying a stock. Okay. Max is what is the maximum profit I'm getting out of. Okay. So now let's dry run how we are going to solve this one. So initially min, I'm treating it as a integer max value, because I'm going to consider my very first as a min. Okay. Then max profit initially 0. Okay. Now let's say this one. Is prices of I less than mean? Yes, that means I can buy at this. It is possible, right? We never know the input array. Maybe somewhere we are going to have 70 and which is the highest profit. We never know. So we can buy at this position, right? So min is going to updated with 7. Great. Then I check is prices of I. What is the my maximum profit? 0. Is prices of I that is 7 minus mean is it equal to, oh sorry, is it greater than my max profit? No. If I buy on this day and if I sell on the same day, I'm going to get zero profit. So which is not greater than this. So what I'm going to do? I'm going to move to the next day and I'm keeping my max profit as same 0. Then I check is mean is prices of I okay less than mean yes that means I can buy at this price which is the minimum so far. Then I check max profit is prices of I minus mean greater than 0. No, 1 minus 1 not greater than 0. It's still 0. So my profit remains the same 0. Then I come here. Is this less than mean? No. Okay. And is this minus mean? Okay. Whatever I'm going to have 5 minus mean. What is that? 4 is greater than max profit? Yes. Then I'm going to update my max profit. Great. Then come here. Is this greater than mean? No. Is this sorry less than mean? No. And prices of I minus mean. Okay, what is the mean? 1. So 3 minus 1, 2. Is this greater than max profit? No. Then go ahead. Is this less than mean? No. Is prices of I 6 minus mean greater than maximum profit that is 4? Yes, because it returns you 5. Then update the maximum profit 5. Then we'll come to the last element. Is this less than mean? No. Prices of I that is 4 minus mean greater than max profit. Current max profit is 5. 3 greater than 5. This is not false. Then we don't update the max profit. So now if you see carefully, so at the end of this iteration where we iterated only once, that is big of n time complexity, where n is the number of elements in the input, and you got your expected output, that is nothing but 5, right? So basically try to understand we are going to have two variables min and max. Min always points to the what is the minimum amount at which I can buy a stock. Max profit, what is the maximum profit I can get if I sell on the given day considering my min. So max profit equal to your prices of I. Okay, your prices of I. That means the current day price minus your min. Okay, this is the maximum profit, and you are going to update this for every day if it is giving you the more profit. That's all for this explanation. Optimize. So the time complexity is big of n, the space complexity is going to be big of 1. Okay, let's go and submit the code. So in order to save some time, so I already submitted. I'm going to let me refresh. Okay, so here I got a time limit exception. So the same code, right? So as I said, for big of n square time complexity. So if I submit this, I got a time limit exception. But we'll see this optimized solution. Okay, so if we take the optimized solution, okay, where I said we are going to have these two variables. So let me take this complete and then paste here and then perform submit. So basically this is what I'm doing. If prices of I is less than min, that means I can buy at that minimum. I can treat that as a minimum to buy. And if other case, and I can see the maximum profit. So you can see it got submitted successfully. And that's all for this video. I hope you learned something new today. Actually, I'm planning to cover more variants of this buy and uh, best time to buy and sell stock problems. There is I mean, best time to buy and sell stock 2, 3, 4 with some variants. So, but I'm trying to cover those when I actually start solving the dynamic programming problems. But till that, this is our learning. So let's mark our tracker done. And we're done so far 8 out of 75. And I agree, I'm taking more time to upload videos, but starting from today, I try my level best to complete this lead code 75 questions as early as possible. Till the next video, stay learning. Thank you. Bye bye.